Why is China able to replicate Soviet weapons, but not American ones? Actually, many of our weapons bear traces of Soviet designs. For instance, our first aircraft carrier was an upgraded version of the Soviet Variag. Our H-6 bombers are based on the Soviet Tu-16 bombers. Even our first-generation fighter jets, the J-5 and J-6, were developed referencing the Soviet MiG-17 and MiG-19. The second-generation fighters J-7 and J-8 were modeled after the MiG-21. In the 1990s, we introduced the fourth-generation Su-27 fighters and even acquired the entire production line. Initially, the components were assembled domestically using Soviet parts, but later, as we fully absorbed the technology, we achieved complete localization. This led to the development of the J-15 carrier-based fighter and the dual-engine bomb truck J-16. Take our first-generation main battle tank, the Type 59, as an example. It was a direct copy of the Soviet T-54 tank, with full production technology and blueprints brought over in the 1950s. By 1959, we had achieved complete localization and named it the Type 59 tank. However, when we imported the American Black Hawk helicopters in the 1980s, things were different. At the time, the Black Hawk was the only helicopter capable of operating above 3,000 meters. Due to subsequent restrictions, we tried reverse engineering the Black Hawk, but failed. This shows a stark contrast between Soviet and American exports. Soviet transfers included both technology and manufacturing processes, which allowed us to gradually localize production. American exports, on the other hand, only included the end products without any accompanying technology or blueprints. Even with advanced reverse engineering capabilities, replicating American military technology remains challenging. U.S. equipment is highly sophisticated and tightly guarded. The U.S. invests heavily in R&D and maintains a robust defense industrial base. They export with confidence, knowing their designs cannot be easily reverse engineered. Hence, even stealth fighters like the F-35 are exported. Furthermore, the most complex part of aviation technology is the engine. Replicating engines requires exceptional material science and manufacturing precision. Even if all the components are identified and measured, reproducing them to the same standard is immensely challenging. Engine performance is highly sensitive to even the slightest variances in component tolerances. For example, in the case of Black Hawk engines, we were unable to replicate them. However, we succeeded with French helicopter technology, leading to the development of the Z-8 and Z-9 helicopters. These were based on the French SA-321 Super Freeland and Dauphin designs, and over time, they were localized and improved upon. Today, China's advances in military manufacturing have reached global standards. Our primary fighters, the J-10, J-16, and J-20, have long been equipped with domestic WS-10 tying engines. Even the J-15, which had been relying on Russian AL-31F engines, has recently transitioned to Chinese engines, marking the complete localization of our fighter jet power systems. The performance of the F-19 has already reached the limits of a turbofan engine, leaving little room for further breakthroughs. For years, U.S. engine technology has stagnated. Meanwhile, due to imperfections in domestic engines, Chinese fighter jets have long suffered from the heart disease problem, particularly affecting fifth-generation aircraft. However, there is nothing the Chinese cannot achieve. If other countries can develop something, so can China. Engines? We'll make our own. This led to the development of the WS-15 engine, which boasts a thrust of 18 tons, surpassing the F-19's maximum thrust by 2 tons. Who can still claim that domestic engines are inferior? Let's not talk about service life, as this is highly classified information that outsiders cannot know. Regardless of whether it is high bypass or low bypass engine technology, we have overcome these challenges. Just as we have achieved breakthroughs in 5G chips, our next industrial crown jewel is just around the corner. The latest batch of J-15 jets is now equipped with domestically produced turbofan engines, officially marking the beginning of the 100% domestically powered era for Chinese fighter jets. Since the J-15 is a carrier-based aircraft with high engine performance demands, it previously relied on the Russian AL-31F engine. But now, China's domestic engines have matured, and we are no longer at the mercy of others. Critics of Chinese engines must reconsider. Our engines are now on par with, if not superior to, those of the U.S. For instance, the most advanced small bypass ratio engine in the U.S., the F119, has a maximum thrust of 15.8 tons. In comparison, our WS-15 achieves about 18 tons. Though the F119 is a product from 30 years ago, U.S. engine technology has barely progressed in the past 3 decades. The only significant breakthrough is the F-135 engine used in the F-35 fighter jet, which has a thrust close to 20 tons. However, the F-135 is a high bypass engine, incomparable to the low bypass technology of the F-119 or WS-20. China's turbofan engine development dates back to 1964, with the WS-6 designed for the J-9 fighter. Though both the engine and aircraft were eventually canceled due to high technical requirements, research resumed in 1987 with the WS-10 project, which entered mass production in 2006. The WS-10, used in fighters like the J-10, J-11, J-16, and J-20, was later improved and remains in use today, including in the newer J-15 variants. Despite its advantages, the WS-10's thrust still couldn't meet the needs of the J-20, leading to the creation of the WS-15. The WS-20, a derivative of the WS-15, powers the Y-20 transport aircraft, addressing the technical bottlenecks of earlier generations. China's military modernization reflects a shift in strategy. From a peak of 6.27 million troops to the current 2 million, the focus has moved from sheer numbers to efficiency and advanced technology. Modern conflicts prioritize advanced weaponry over manpower. For example, China's rocket artillery has a range of up to 400 to 500 kilometers, capable of striking distant targets with precision. Similarly, advanced satellite systems ensure precise monitoring and deployment of forces, making our smaller but highly equipped army sufficient for modern warfare. The introduction of high-performance engines like the WS-15 signifies China's ability to overcome technical challenges. With powerful equipment and a streamlined military, China is prepared for both regional and global challenges.